Hello, everyone. I'm Sky, and I'm going to be talking to you about salmon in the Pacific Ocean. A little bit of background. There are 5 species of salmon in the Pacific: Chinook, sockeye, pink, coho, and chum, and they are all under the genus Oncorhynchus. And they are also all anadromous, which means that they begin their lives in freshwater habitats, migrate to the ocean at maturity, and migrate back to their home stream to spawn. So a little bit of history of salmon in Washington state specifically. Native American tribes from Mexico to Alaska used to depend on them for food and livelihood. Hundreds of years ago, 16 to 20 million salmon would return just to the Columbia River in southern Washington annually. However, salmon populations declined throughout the 19th and 20th centuries due to overfishing, the timber industry, habitat destruction, human population growth, agriculture, and dam installation. There were treaties with tribes in the United States to support tribal fishing. However, these really were not upheld until a 1973 Supreme Court ruling, which mandated that 50% of all salmon fishing rights belonged to tribes. And there was actually another Supreme Court case in 2018 that mandated that Washington state remove any fish barriers that are preventing salmon spawning. So the salmon life cycle. Salmon begin their lives as eggs in gravel nests called redds. And once the eggs hatch, the fish remain in the gravel, feeding off of their egg yolk sac, and they're called elevens. After the fish emerged, they're known as fries. And as they mature, they develop these stripes, which are called parr marks, and you can actually identify the species using the parr marks and the dots on the top of the fish. When fry start to migrate to the ocean, they begin the process of smoltification, which is where their scales become silvery and their systems convert to saltwater. Once in the ocean, they'll spend 1 to 4 years there, depending on the species, where then they'll return to their home stream to spawn and pass away. So the salmon food web. Pacific salmon eat mainly zooplankton and smaller fish like herring, which are known as forage fish. Those shrimp and krill are part of their diet as well. Different salmon species have different preferences, though. Sockeye, pink, and chum eat mostly zooplankton, while Chinook and coho consume mostly forage fish. Biomagnification. So depending on the species, salmon are either secondary or tertiary consumers, which means they are a victim of biomagnification, though not to the same extent as their predators are. Organisms that eat adult salmon, like sharks, orcas, seals, and some others, are all subject to further biomagnification from their salmon diet. Looking at ENSO, you see in this first picture the El Nino cycle, where the Pacific Northwest is much warmer. This means less snowmelt, less water in streams, and warmer waters on the coast, which leads to less upwelling. So not only is the habitat worse for salmon inland, it's also worse for salmon in the ocean. Over here, you see La Nina years where the Pacific Northwest is colder and wetter. So there's more snowmelt, more rainfall, the streams are colder, juvenile salmon are better off, and there's more coastal upwelling. So adult salmon in the ocean are also better off. What's really unique about anadromous fish is that they use chemical cues and magnetic fields to find their way back to their home stream. Salmon imprint on the magnetic field that exists where they first enter the sea and later seek the same field when they return. They then use chemical cues to identify their specific home stream. Looking at the graphic, you can see how stronger magnetic fields means more salmon will use a particular entrance as a migratory route as they enter the coast on their way back. Effects of climate change. So salmon are becoming smaller because there's less food in the oceans due to ocean warming and less upwelling. They also have more competition from hatchery salmon. Development is also ruining habitats, so there's less areas for salmon to spawn. Ocean acidification, there's less prey, less energy in the oceans in the ocean food web. Warmer temperatures mean warmer streams, and juvenile salmon do need cold streams in order to thrive. Droughts are a similar problem, and also streams can just dry up, which would strand all the juvenile salmon that are stuck there. There are some protections in place, especially in the Pacific Northwest. As I mentioned before, the state of Washington has a legal requirement to conserve habitat for fishing rights and is currently in the process of removing the worst fishing spawning barriers. We also have the Pacific Coastal Salmon Recovery Fund, sponsored by the National Oceanic and Atmospheric Administration. In Oregon, the Oregon Watershed Enhancement Board has funded over 20,000 projects that support and improve key salmon habitat. There's a lot more I haven't mentioned, but salmon's a pretty big deal in the Pacific Northwest, and we are lucky to have these protections in place. However, there will be much, much more to do in the years and decades that come. Thank you for watching. Here's my sources, and here's where I got my pictures.